Thank you very much, Doug, for the introduction. I think you said it all. What maybe Doug hasn't said is that I'm a philosopher by background. Do you hear me okay? Yeah, okay. And you will get more of the philosopher in me today. I've been the kind of the person who's between policymakers and industry, or who understands quantum the rest of the week. And those who've seen me a lot, I hope there's also something new in what I'm planning to share on this. And to start with, I actually want to do a little, and I don't think anyone has done this with me, but have you guess who, so philosophers start their talks typically with quotes. I didn't want to do slides because I thought it would be much more engaging if I didn't. But I'll read you a quote and I'll ask you to guess who said this, or who more, actually he didn't say it, so I'm giving away, it's a he, sorry, but who wrote it. It's a bit summarized, but it goes as, overstretched promises may eventually come to haunt the very scientists who are making them. If quantum technologies are to be meaningfully disruptive, they should not be developed in ways that merely extend the status quo, uncritically reproducing prevailing societal conditions and unsustainable values in the quantum future. Do you have... Richard Feynman is a good guess. Exactly, it's a go-to. It wasn't Richard Feynman, but I would say, Barry can correct me, but I would say the person is on similar terms, or in the similar... I look at the physicists in the room. You will have read a lot of this person's papers. He'll been quite influential in terms of, now I give it away, defining quantum computing. Deutsch? No, it wasn't Deutsch. It's Davide De Vincenzo. So you might not know, but Davide De Vincenzo actually wrote a paper on quantum in society. It's a very short paper, but the reason I emphasize it is that actually many physicists don't know this paper. So physicists will know Vincenzo and they will have read everything of him, but the one paper they won't have read, or likely won't have read, is the quantum in society paper. It's, I think, from 2010. It's very, very short, but at least I think the reason I use that as scene setter is that it shows us that a little bit the caricature that we're sometimes painting from the responsible quantum world, that physicists don't engage with society, don't think about these issues, don't think about what's happening beyond the lab, isn't entirely true. I think we have one among us. Barry is a very good example that this is not true. We have a lot of now more examples that this isn't true. But I still think it's important to bear in mind and to not to overuse this caricature of the physicist. And I think that leads nicely into communication about it. So writing these kinds of papers, and even if they're papers that might not be as highly published as a scientific discovery, writing these papers is really important. So in a way, I'm already starting with a kind of call for action, is that if you have these thoughts about what the impact of quantum technologies are, do write them in papers, do publish them, because that's a way of communicating them. And even if it's a language that you're not familiar with, do collaborate with a social scientist or someone who can help translate you this language. You'll see that translation is a bigger theme of the remarks I'm making. So there's two big themes in a way that I want to focus on. So one is, and this is again the philosopher, around epistemic access. I'll explain what that means in a second. And the second then is around translation. So when I think about communicating quantum technologies, I think a lot around these two issues, around epistemic access and translation. Epistemic access means access to the knowledge about quantum computing. We talk a lot about access to the hardware. We talk not sufficiently about access to the knowledge around quantum computing as an issue of epistemic injustices. So this is, again, the theoretical philosophy part, and also I should say this is part of a paper I'm co-authoring with Carolyn Tinholter, who's been really influential in the sort of responsible quantum sphere, and who's at Oxford, and Natasha Orton, who's at the NQCC, who actually leads the Responsible Quantum Industry Forum. So two also distinguished colleagues of ours. So the ideas that I'm sharing around this are from this paper that is to be published. But you'll find them in there if you want to read more on this. So the idea of epistemic injustice, epistemic justice, is a relatively new idea by a philosopher called Miranda Fricker, and she essentially holds on to theories of justice, distributive theories of justice, to say that not only should we talk about redistributing goods, and we have a lot around, unequally distributed goods, but we should also understand knowledge as something that can be issues of distributive justice around. So she kind of promoted that. I won't go into too much detail with that, but just to say that I think what we're currently facing in terms of the quantum divide is also a situation of unequally distributed knowledge around quantum computing. And you can reframe that I think that is a statement we would all agree with, or we're all discussing a lot, but you can reframe that in terms of epistemic injustice. So I think it gives it more power to point and say that it actually is an issue of injustice. As moral philosophers, that gives us a lot of power on theorizing what to then do about it if we can say it's a form of injustice. So I think it's a very powerful conceptualization. So when we then talk about, and then the obvious solution is, well, there should be more access to knowledge around quantum computing. But then if we go into that and think about further on, well, access to knowledge about quantum computing, it could initially mean, well, okay, then make everything, accessible and kind of put it all out there and so on. And that's more or less what is happening. And if you, for instance, then talk to kind of academics, they'll say, well, but we're publishing, and industry will say, well, but we produce these YouTube videos, everyone can go there, it's all out there. But there's an issue around putting stuff out there and people then actually consuming what is being put out there. So there's one issue around access doesn't necessarily mean that the access is used. But also there's an issue around what we assume what everyone needs to know. And I want to go a little bit deeper into what are the assumptions we're making around what different stakeholders need to know. So I'm using the four kind of stakeholder groups of policymakers, academics, and industry and civil society, and want to reflect a little bit on what does everyone need to know everything, or is it actually okay if there's this division of labor and that we have in society, and what does it imply for quantum technologies? Because I think we often, at least when I give talks to policymakers, one of the first things I'm hearing is, oh dear, you're talking about quantum, that's far too difficult. I'm not a physicist by training, I won't understand any of this. And I think this kind of excuse comes with the assumption that in order to understand quantum, that they would need to understand everything, that they would need to understand what entanglement is, that they would need to understand exactly how a qubit works. But that is, of course, I say of course, because that's my argument, that is not the case. So what is it then that each of these groups, in our view, that we have in the paper, needs to know? So policymakers need to know enough to make sensible regulation. We heard this week about not so sensible regulation, or regulation that was far too late. So they need to understand enough of the technology in order to, when they write text, to make them technologically sound and scientifically sound so that they actually make sense. Also that they show there's an understanding of technological roadmaps. But they also need to understand enough to anticipate for their respective country what the impact of quantum technologies is. So even if a policymaker is not involved in regulating quantum technologies, they need to be aware enough to say, oh, actually, maybe we have a strong fertilizer industry. Fertilizer involves a lot of biological simulation in order to develop that further. Maybe quantum is actually really relevant for us, and to know enough to then actually build a quantum ecosystem or start building a quantum strategy into its system. And on the security side, they of course need to know the roadmaps around the potential threats and what to do, and also in order to, again, put regulation and recommendations around when to implement PQC algorithms. Also, importantly, they need to understand where PQC is post-quantum cryptography is relevant, and where quantum key distribution is relevant and where it is not, and that it's not the same and kind of also not replaceable. So this is, I think, the elements that the level at which policymakers need to be aware and what they need to understand. In academia, of course, the assumption is that the physicists understand quantum, but I put understand in quotation marks because who really understands quantum, but also understand enough to work with it. But then we have computational biologists, for example. They need to understand it enough in order to see, well, is quantum computing relevant for me? And if it is relevant for me, what do I need to do in order to use it in the future so that we actually have good algorithms and actually can make uses of the systems that are being developed? But then across disciplines as well, we need to have a way for social scientists to understand quantum enough, or for the philosophers to understand quantum enough to develop good quantum ethics, or to develop at least an exchange about it. For industry, I think one should divide them into users and developers in industry. But users need to understand the impact, they need to understand the roadmaps, and they need to understand how to use if they want to be users. And I think it's really, really important that they understand how to evaluate different quantum technologies. In my particular case, quantum computing, how to not fall for the trap of thinking, well, it's the number of qubits that counts, but also know what are the other criteria by which to judge, for instance, a quantum computer in order to say whether a breakthrough was actually a breakthrough, and in order to read announcements such as this February's announcement in an educated way. And the same is then for developers, and I think this has been said before, there's more of don'ts. And I think I've written 3 bullet points here, but they all say the same, because there's really just one key message. Do not hype, explain in a humble way, and do not oversell. It's all of the same, but that's basically the main for industry developers. For civil society, and this is where I want to go a bit further again, and I'm making the assumption of democracy here, is that if you go, for instance, with what Hannah Arendt has warned us about in The Human Condition, is that the danger with what technology allows us to do, it's not really with the danger of what technology allows us to do, but really with what we stop questioning once it can. And so if we stop questioning, it really takes away everything that we have as our critical nature, which takes away from our human agency. So if we stop doing that and we stop trying to understand, really, are we still human agents in democratic systems? So purely for democratic accountability, also civil society needs to understand enough to hold policymakers accountable, to understand the risks, and to advocate for more regulation where necessary. And so I think this is crucial, and this is where it comes back to epistemic injustices, where there's a crucial issue for our democratic systems if we cannot uphold that. So this then goes into, well, what are then the norms for translation? And of course, so there needs to be translation between these different stakeholder groups. Translation, of course, involves senders and receivers. And we all know that there can be big misunderstandings between senders and receivers. So one of the key tenets is that for translation, you need to be in any way as clear as possible. And for the receivers, you need to be as open and generous to the sender as possible. But I took 3 examples. So what does it mean for when academia sends or tries to translate to policymakers in industry and civil society? I think there's a certain element of non-arrogance that is needed. Often there's this element of, well, no one will understand this anyway. And this is prevailing, unfortunately. And so this then goes into, oh, if I have to explain this to an audience that isn't from a physical background, I have to simplify, and by simplifying it's uninteresting. And so the talks get very kind of, well, done out of duty. But I think there needs to be kind of an element of that simplification, and translating is not sort of just a duty, but that can actually be quite an intellectual challenge to do it well. And I think we see a few examples of those who are doing it well, and I would hope that they find it intellectually stimulating, but also to do away with some of the statements that have been made by past physicists, like overemphasizing the quantum is spooky action at a distance, and thereby scaring everyone up because one physicist said it's spooky. I don't think we need to replicate these myths around quantum computing, and kind of also don't fearmonger around it. But also don't amplify. Assume that your audiences are epistemic, are well educated, and also have epistemic capacities, have the same epistemic capacities as you. Don't assume that their epistemic capacities are inferior to yours. For civil society, for industry communicating to civil society and policymakers and academics, it's be down to earth, don't oversell, I said that already. For policymakers, it's also to involve scientists and industry and listen to them. So there be good listeners. And don't pretend you already have seen this before, but listen again and listen better, because we haven't figured out a good way for policymakers to engage with scientists, and we haven't found a good way for good tech policy. And then for listeners, I said listeners need to accept the unknowns. So there is a lot of unknowns, and often that's hard, so don't do the kind of bullying that Barry mentioned. Accept that there is a different logic, but that doesn't mean it's too hard. And sort of have this practice of openness and generosity. And so in practice, what it means is, for instance, and I'm going to come back to the Open Quantum Institute again, but this is why kind of this element of translation is why we have this element on education of broader audiences, so for students, through hackathons and through lectures and so forth, through also putting the physicists in our community together with students and really enabling an exchange there, but also have this education of policymakers to enable them to really be anticipatory and also do kind of experiential learning through something like the quantum diplomacy game. And also around governance, that we need kind of an open, or allow this maybe to be an open forum for multi-stakeholders to meet and to exchange, to have this translation element, to understand from each other, together with institutions like the OECD, like UNESCO, also building on initiatives like the International Year of Quantum, that is mainly, and you heard, if you attended or watched the opening ceremony, that one of the main aims of the International Year of Quantum is to make people more aware and at least make people start questioning around what quantum technologies are. So with that, I close.
Thank you.
So Mira, you've